Imagine a power plant that built itself and kept running for hundreds of thousands of years before humans ever walked the earth. This isn't science fiction. It happened deep in what is now Gabon, Africa, about 2 billion years ago. A cluster of uranium-rich rocks became a natural nuclear reactor, and it behaved more like a living machine than a lump of ore. Here's the twist that makes it possible. Back then, the fuel itself was different. A heavier fraction of uranium-235 existed naturally. The conditions were just right. Groundwater seeped into the ore, slowed neutrons, and a chain reaction sparked. Heat rose. The water boiled away. The reaction died down. The water cooled, returned, and the reaction restarted. It cycled on and off for perhaps hundreds of thousands of years. Pause on that image. Nature creating a feedback-controlled reactor with cycles of ignition and shutdown, without valves, operators, or blueprints. What scientists found when they drilled into those ancient rocks stunned them. The isotopes of xenon, neodymium, and other elements showed the unmistakable fingerprint of sustained fission. Some fission products had migrated only a few centimeters before getting trapped in mineral cages. The site became a snapshot of what nuclear waste does over geological time. This natural reactor taught us two impossible-sounding lessons. First, geologic materials can trap dangerous byproducts far better than we feared. The ancient rock prevented many products from leaking away. Second, the whole system self-regulated. The boiling water acted like an automatic safety system, throttling the reaction without human intervention. But the story gets darker. The reactor left scars. It altered local chemistry, produced heat that changed surrounding rocks, and forever rearranged isotopic ratios. And it raised a terrifying possibility. If planetary conditions and concentrations line up, nuclear reactions can ignite wherever uranium and water meet. That idea ripples outward. It reframes how we think about planetary habitability, about natural high-energy processes on early Earth, and about how to store our modern radioactive legacy. We studied nature's reactor to design better waste repositories and to imagine reactors that shut themselves down the way an ancient aquifer did. So the next time you think technology is purely human, remember this. Earth once built a nuclear power plant and ran it like a slow, obedient heartbeat for ages. It's a humbling blueprint buried under our feet. If that blew your mind, hit follow and dive deeper. There are more ancient technologies hiding in plain sight.